So let's get on and let's code it. So the very first thing I want to do is I want to create my class, which is going to wrap my integer array. This is an array of integers. So I'm going to make my own. I'm going to call it int, short for integer, array. I could call it integer array class, but I'm going to just stick to integer array because it's a reasonably clear term for the name of my class. Right? There's my class, nice and empty. Now, first question you might ask is, oh, okay, first thing I'll do is I'll get my public static void. No, do not write public static void into this class. This class is not a static class. It is entirely designed as an object. Objects tend to sit on servers. Servers don't know how they're deployed in the user interface. So you don't use static material inside. You don't have a main inside here. You have a raw, empty class. Only what this is where we're shifting our approach. There's your main, and what we're going to do is we're going to create the object of our int array in here and do stuff with it. But this doesn't need its own public static void. Now I'm saying that thinking, I hope that's clear. I have no idea when I'm saying it to you whether it is. But I'm going to proceed. If it isn't, please raise it as a question in the class. So, private. My data is going to be private. And what am I going to do? Let's go over to my program. That's my reference, the name I've given to my integer array. So let's just grab that, copy that over, pop it into here, and put a semicolon. Now, notice it's not sitting inside anything other than the class. It is entirely just in the class. There is no function or method visible in this int array. What I've actually done is I've created this. I've created a reference to an integer array inside my class, and it's invisible. Right? Let's just test that out. Well, test it out in a minute. Okay, that's the first thing to notice. Actually, in my lectures, I do test it. So let's carry on and follow that procedure. Right. So let's come up here. And it's called int array is the name. Int array is the name of my class. And there we go. There's a nice little tab 9 help. Empty bracket. Let's just double check. Cannot resolve symbol int array. Let's just get it to resolve. Bear with me. I think I do need to import it. That imports console. Give me a second. I need to have a similar, because it's sitting in a subfolder called object. So let's pop it in there. There we go. There's int array. There we go. Right. So that's actually just a subfolder. Think of it like a folder path when you look at this import line, because my objects folder is sitting underneath source, but the program is sitting in the source root folder. I need to navigate to the subfolder to get access to it. Okay, so let's not call it array. Let's, for sake of simplicity, just call it IA, short for integer array. There I've created my integer array. Now, first thing you want to do is I want to see what I can see inside it. So if I do IA dot, it has a whole ton of stuff in here. And you might say, hang on, you didn't build any of this. What's all this stuff? Well, this is the one interesting thing about programming object-oriented code. It comes with pre-supplied with a whole bunch of inbuilt functions. We're not going to linger on those at the moment. The one you might notice is toString, and I'm going to get you to avoid that for the time being and avoid all of this stuff. We're only going to look for the things we create. And there's a good reason we're doing that, because we're learning to program here. Right. Oh, at the moment, I've just created my object. It doesn't do anything. Right. Okay, so really, let's take it a step at a time. Now, that step asked me for my size of my array and got the array size. Okay, that's fair enough. But this line created my array. So I need, my first step is ready to replace that line. I need to initialize my object, this object here, with all of this stuff, because I want to remove this line here. Right, it's going to mess up all my other code, but we'll take it step at a time. Okay, so in order to do that, I need to create a new array using the size given to me by here. Now, that line of code creates the object. But at the moment, it doesn't receive any initialization data. So it doesn't say anything as soon as at the moment you create the object. What I actually want to do is where the cursor is flashing, I want to pass it the array size. And I'll tell you why. Let's grab that line and let's put it. This is a like for like comparison at the moment. So in here, in my array, I want to do that. Now it's going to complain, and we're going to resolve that complaint. And it's going to have lots of complaints further down, right? So what we'll do is we will temporarily just comment it out and uncomment it as we go along. Okay, so the very first thing to do is let's leave that in there. Right, so there's a like for like comparison, and you think, hang on a second, why is that complaining and what's the difference? Compare the two lines. This is my object IA, creating a new one, and I'm passing the array size, but it's complaining. Whereas this is just the array itself. So look at that line there. I need to take that line and pop it inside my code. How do I do it? Where does the code that this line, when I use a new word, actually execute? And it's called the constructor. Come to your integer array. Now this is a nice thing about this environment is you can right click, go to generate, and choose the different things to generate. The getters and setters, which I introduced in another video, you can actually generate. You can actually generate the toString and edit it. You can generate override and overload, all kinds of methods, but we're going to generate a constructor. But we're not going to give any parameters to it, and it's going to give me a blank constructor. Now, what's a constructor? Constructor is, and ignore the one related problem, right? A constructor uses exactly the same name as the class. It doesn't give anything back, so it's just public. The name of the constructor is the name of the class. What it does is it allows you to pass initialization data. So if I put in here array size, for example, and then inside this constructor, there's my array, int array, right? And I do that line new int. Let's go back so you can see it in the actual program. What did it do? It did this new int array size. We'll use the same. Okay, so it did that to create a new using the size. Let's grab that, pop over here and pop it into here, and let's make both of those say array size. Okay, so I've got two of those, that's why it's not happy. Now what has it done? What it's actually done is my constructor has received my one value, then it has created my empty array inside my object. Right? I've wrapped the process, and I can tidy it up even more by simply doing this, right? Because it's only one line of code, let's just pop it all onto code to keep the simplicity visible. Grab that there. Now, what's really interesting about this, and we'll come back to the program, all my red lines have gone. Over here, I can get rid of that. What that line of code now does is it receives the size and it jumps to this constructor code, takes the array size and sets the size of that internally stored array. But from the user point of view, I don't need to see the array being built. I just see my object being built and initialize with the array size. So not a huge difference at this stage. And this is why you've got to be a bit patient with objects. Okay, so make those code changes. Next up, we were going to populate it. So I'm going to do a like for like comparison. I'm hopefully going to make the code simpler. Right, let's uncomment that. Number is my uncomment. That will just, there we go. And let's edit it. So this uses the index. It's referring to the integer array length. I don't have access to the length. So that's one thing I could do in my integer array. If I go over to my class, I create a public, and I'm going to return the length of the array. So it's an integer. And if I say get length, right, it's tab 9 has very cleverly spotted what I'm trying to do. And I'll just select it. That will return the length of the integer array. Let's come back over here. So I can take IA, and you might say, hang on, now not a huge difference between the two. Get length. That's not a huge difference. You say you're still using this loop. Okay, bear with me. We'll take it a step at a time. Right, so we're getting an array value and we are writing it to the index position of the array. So that's where things get actually quite complex. Now, why are they complex here? And why you might constantly be saying, hang on, but this is so much more complex. What's the value of it? What's the benefit? Well, we have to go through this process for you to fully see it. I don't want to muck around with indexes. I'm going to solve this problem by creating a method inside my class called public. It doesn't return anything. It just appends. And what does it append? Right? What is it? It receives an integer, some value, and what it needs to do inside is something like this, right? Hang on, bear with me a second. Something like this. But let's just grab that line for a second, drag it into here and see why it won't work. Well, it won't work because I don't know what index value I'm at, right? I need to manage its appending process internally. So this is how I can do it. It's going to give you a suggested, and now you will see straight away how working with an object, because the biggest issue is hiding everything inside, it has a level of complexity straight away. But bear with me, because you will see that this is how everyone codes objects, why they actually scale up much better. What looked so simple in this program and was easy to do only gets you so far. Go back 20 years, no one will complain with that code. Come to where we are today, everyone will say that's just too basic. So it does have an overhead. Now what I'm going to do is I'm going to create an index value and set it to 0 when you create the object. Now that's an alternative way of actually initializing it. The better way of doing it is actually in my constructor, which is the place it should really happen, is I declare my index value there, and then inside there I actually set it to 0. That's probably the better way to do it, right? So when I initialize, I set this index to 0. Now what I do is I come along here, I want to add it. It adds, it uses the index value, which right at the beginning will simply be 0, right? Once it's added it, it then internally increments the index. Okay, so you think, okay, that sort of seems all right. That will take each index. I don't need to worry about passing an index to it. I can just call my append, pass it the value here, and it will manage, to add it to the next index position in the array. Okay. Now, if you're confused with indexes, you've got to go back to week 3 and work with arrays, because I'm not going to spend time with that here. That's something I'm assuming. So you need to pause, go back to week 3 and be clear about how indexes work. Okay. So on my program, I should just be able to replace that line there, comment that one out, and replace it with my object dot append. And the value I'm passing it is this value I get from my user. Now, there are two things that appear here. And we haven't fully solved the problem, and I'll tell you where the issue is, and some of you who already might have spotted it might spot it in a minute. We'll look at how to shift all of this, okay? Because if you ask me, this is all really, really quite complex and messy, and I'd like to try to avoid using a counter. If I don't need this I value anymore because I'm no longer using it, then why am I using a counter-based loop? Right, good question. We're going to edit that in a moment, but look at this. That actually says what it does, appends that value to this object. So straight away, it is already clearer than using an indexed notation on an array. Okay, you might disagree with me, but the more and more you learn to code with this way that you will find. Now we've got another issue. We've got this hideous loop which uses a counter, counts and populates according to the counter. But look, hang on a second, you say to me, if I am creating code where I can, let me grab a bit, where I can internally manage that index. Why do I need to have these indexes out here? I don't need them, do I? Surely there must be another way of doing it. Yes, there is absolutely another way of doing it. So let's go back to our class and ask it a question. Okay, and see some problem with this append method. If I'm appending, how do I know that index hasn't gone outside of the boundary of that? I need some way, because I've got a method here which tells me the length. Then that index, I should only append as long as that index is less than the length. If it's equal to or greater than the length of the array, it's actually gone outside the length of the array. So internally in the append method, before I even start appending, I can ask it a question. And if that question, because I'm returning void, I can just exit the code. So what I'm asking it is if the index is greater than or equal to the length. Have a look at that code. So look at my append method now. I'm saying if the index, which is incrementing every time I add an item, now say I have 5, the size is 5, so the length is 5. So I've got 0, 1, 2, 3, 4. Theoretically, I'll hit 5, right? Because the previous add will just mean that when I come back around here, index has now 5 in it. This is what we mean by state, the state of the object. This is a value which defines a certain aspect of its state. That could be 5. If that's 5, that's greater than or equal to that, it won't continue. It will just come out of the append method and it won't add any more and it won't crash. So that's one really, really simple way of doing it. We can take this concept even further. The get length is actually quite useful. Why don't we create a method to capture that single line of code with the concept? And this is another way of doing it. So I'm going to introduce this. We're going to create a public boolean and we're going to ask the question, is array full? And what this method is going to do is it's actually going to use that. Let's grab that bit of code. It's going to do two things. If it is full, i.e. it's the same, then it's going to return true. But if it's not full, come out of the if statement, think about the logic. It will run that, it will do that and leave this function. If that's not true, it will return false. So actually that's a simpler way, and IntelliJ will tell you it can be simplified. Please don't keep on simplifying stuff yet. Make sure you get the concept first. Now what I can do is I can take my own method and I can make that private or public if I want to use it, and actually ask the question here, is array full? Now by doing those two steps, when I append, the first question I have and I ask, is the array full? Well, if it's true, then it won't add. So now I can create these functions inside my own class, my own object, to help me move around it. So I now have a very useful function which I've made public, so I could use it externally. Interesting. That's actually going to give me true or false. Then I could come back here and I could replace this with a while loop. How would I do that? How would I use a while loop? Let's have a look. Let's write it above it and then we'll replace the line. While deals with conditions. Okay, so what's the condition? Well, I say to IA, is the array full? If that's true, then I shouldn't continue in the loop. So I want to say if it's not full, and the way I do it is I put an exclamation mark in front of it, and I can get rid of that. And so I now have a while loop which is asking the question. There's my array size. I've created my object. I don't know from the client point of view how any of this is happening, so just focus on this. I then say, as long as the array is not full, grab an item, append it. It then whisks around here, asks that question again. Inside your code, it asks that question, and it will stop you from adding over the end of your array. So that actually can now compare the previous code to this. Bit difficult because it's not side by side. It may help if I just grab it from the worksheet. Give me a second. Now, you might argue this is so massively subjective. It isn't subjective at all. What's visible to me, go back to the worksheet and compare it to the worksheet, okay? It's on another screen, and I don't want to drag it across for the moment. But what I want to emphasize is look at the way the code reads now. Create my console function thing. I get my integer, so it's clear what's going on in that line. I create my object. You might wrap that and do something else with that, but that line is very common, so we don't worry about that generally. Then I have a nice loop which says while the array isn't full. That's what this exclamation does, is it puts a not. It says it's not. If array full returns true when it's full, this reverses it. I'll let you work out the logic of it, but it's the right way around to do it. It's a way of saying it's not full. As long as the array is not full, that's all you need to ask. Grab an item, append it. So that will populate it from a level of concepts. You're not populating it worrying about the mechanism. You get the object to ask, is it full? Okay, while it's not full, grab an item, append it. Grab an item, append it. Now, some of you might think there are even neater ways of encapsulating these lines of code and creating even a static function out of it and all the rest of it, which you can do. But this is as far as I'm going to go for this introductory material. We have one last thing to do before we finish this particular thing. So code all of these changes before we go. I'm going to pause, open up that screen so you can see. It's actually, I think the bulk of this code is in the worksheet. I'm pretty sure it is. Yes, it is. Okay, let's finish off. The last piece of the jigsaw was displaying the content of my loop, of my array. So we had this rather unpleasant, another counter-based loop and mechanism, and I did each line at a time. Well, why don't I just shift all of that inside my object and just say get the array data? Okay, so how do we do that? Well, this is a very interesting procedure, and this will help you in your coursework because you will use this in your coursework. A lot of what you're learning now will feed directly into your coursework. So patiently, don't rush this material. Let's cut that, let's copy that. Let's go to my array. Let's go and find another blank space. Remember, I'm always finding blank spaces which are inside my class, but outside any other method. And these aren't called in a sequence. This doesn't run in a sequence. These are run whenever I need them. That's the other difference with object-based code. So I'm going to create a function. It's going to return a string, and I'm going to call it toString. Now, this function is technically, it overloads an inbuilt function that is provided to you, and you can try to play around with it, the inbuilt function, and edit it. It's quite an interesting experience. And in fact, because the lecture has this version, me talking it through, why don't we do it the other way around? Let's see whether we can actually just grab that. No, we won't. Sorry, I'll carry on. Right, so I've got a public string overload. What's the message over here? Oops, I didn't want to do that. Out of the object class. Let's go back here. Right, now, this is what I used. I had a loop, and it output each. Now, I can't have output and console stuff because I'm in my server object. Right, so I need to return a string. So we're going to do it in the most elementary way possible. We create an empty string. Right, so we're going to call this string to return. I'm going to initialize it to an empty string. Okay. Then, for the time being, we're going to array size. What's array size? Well, we know we got get length. So we don't want array size. We can just use get length because we're inside. Remember, we're inside our class. We've got access to all the other methods. We can work collaboratively with them, so that's okay. I can iterate through them, but I'm not going to console output it to do any of that. I'm going to take my string to return, and I'm going to plus equal it. Now it's going to say to you there is a much string concatenation in the loop, and you can use string builder. convert it to a string builder and so on. For the time being, don't, but later on when you're confident with it, then do it. Okay, so if I just do that, that will glue each line onto a previous line. Then at the end of that loop, get to the end of my blue, I just return. Return, he says, string to return, and tab 9 tells me. There we go. Right, so that's kind of a really basic version of how to output that as a string. Let's go back to my program. We don't need any of that. We don't need to loop here because all the looping is now hidden away. I just simply go to my console output to thing, and I say, let's get rid of that. I say object ia dot toString. That's my method. It should now display what's inside it. Let's have a look. Run it and open up this window here. Please enter size of array. We'll keep it small. 3. Oh, no, 3. Enter a value 45, 34, and 78. Now the only thing you might notice is that it squeezed it all into one line. So we need to go back into the integer array here and actually do something like this. Maybe put a \n, but actually the string builder and other mechanisms do a nicer job for you. Let's run it, and so it just displays it a little bit neater. Okay, enter length 3, 45, 67, 33. There we go. So that's now all of that code is in my own object, whereas the program only needs to do that. So we have changed our code from something where all the mechanisms were visible to only some partially are relevant here, and the rest are all done inside your object. So we create a console function that's responsible for getting the inputs, output into console, right? It tells us what we're doing on those lines, so we don't need to struggle to understand. We create our integer array, we give it the size from there. We then say, as long as the array has got a method we built called isArrayFull, as long as it's not full, we then get the input and we append it. Append is a fairly clear concept. You're adding it to the array. So this will populate. I would hope that it's clearer for you. And then finally, you want to output to console the object as a string, i.e. the content of the data to a string so you can see it. So I'm going to stop there and get you to code it. The exercises I have attached are for you to do some extra methods, and I'm going to just briefly introduce those for you before we go. What I want you to do is create in here, let's say do it here in this gap here, right? Remember, we're not in anything. I want you to do a public, you're returning a sum, so, and there's an integer method you call sum. Work out what you're going to do inside there and what you're going to return, right? So how would that work? You've got access to the array itself. You know how to loop through an array. You're just grabbing that same kind of concept and you're replacing what's inside. It could be really a matter of copying and pasting and some editing, right? So you can build up the sum. In the same way that you could build up a string, you're building up the sum. You need to build a sum. Can you work out how to then take the sum and use it in another function? Now the average could be a double. So if you're going to ask for an average function, right, which I'm asking you to do, you would need to grab the sum and divide it by, I'll let you remember, the length of the array, i.e. the number of items. That could return a double. That's what you need to return out of that. Return the most frequent. I'm going to leave you to work out how to code that. And the last one is a challenge. And I'm going to, both of the last two are challenges. I'm going to leave you to work those out. In the next video, I'm just going to talk through the worksheet very briefly, and I'm going to hope that you have coded this as we have gone through this.